Hi, in this video we will solve a question from electrostatics. So just go to the question. Two identical charged spheres suspended from a common point by two massless strings of length L are initially at a distance d apart because of their mutual repulsion. Okay. So as per the statement, mass of the string is neglected. So that is why they have given as a massless string. Okay. First draw a support from which two identical spherical balls are suspended because of their same nature. Both charges are the same nature. They are repelling each other. Due to this repulsion, they are certain distance apart from each other. That distance is taken as d. Okay, and the length of each string is L. After some time, the charges begin to leak from both spheres at constant rate. Okay, so the charges are begin to leak. Due to the leakage of charge, the force will also reduce. So because of that force, reduction in force, repulsion force, these two spheres will move towards each other. Okay, so at that time there must be a velocity v. So what we have to find is the relation between the velocity and the instantaneous distance between the two charges. We have to find the relationship between the velocity and the distance between these two charges when they are x meter apart. So let me erase this and redraw with the distance x. So we can take the value as x instead of d. We can take the value as x uh, because at the moment it starts to move, its value will become x. Okay. Now I'm going to draw a line in between these two for my reference. Okay, if the total distance is x and this part will be up to this part will be x by 2, and the second part will be also this also x by 2. Okay, and I am assuming this angle is theta. Okay, now identify the force acting on the first sphere. Okay, we can do this with only one sphere. Identify the force acting on the first one. The first force acting on it will be its self height, that is m into g. Okay, and the repulsive force due to the second sphere, the second sphere will try to push it outwards. Okay, that is electrostatic repulsive force, and tension will be there, that is T. We can resolve this into two components. The first one will be, if this angle is theta, by applying the alternate angles, this is also will be theta. Okay, so this component will be t cos theta, and the horizontal component will be t sin theta. Okay, so let me just redraw this clearly. That looks messy. Okay, this is a sphere. The first one we have mg self height and electrostatic force Fe, and this component is t sin theta, and the upward force is t cos theta. Okay, now we can equate the horizontal force. Equating horizontal forces. Okay, the first one will be F electrostatics equal to t sin theta. The formula for Coulomb force is k q square. Here the distance between the two spheres is x, so we can take that as x square equal to t sin theta. You can take this value as equation 1. Okay, now we are going to equate the vertical forces. the upward force is t cos theta and downward force is mg. So we can take that as mg is equal to t times cos theta. There is no value here to substitute, so simply we can divide equation 1 by 2. Okay, I'm just dividing equation 1 with 2. Equation 1 divided by 2, so I will get q square by x square divided by mg is equal to t sin theta by t cos theta. You can rewrite this as q square by mg x square is equal to, this t and t will get cancelled, we will get sin by cos value as tan theta. Okay, so now we have to find the value of tan theta from this diagram. So I'm just rewriting a part of this diagram to find the tan theta. So this is theta and this value is L, length of the string. We can take this value as height of the triangle, and this will be x by 2. So first we have to find the height value in terms of x and L. Okay, so just find the height value. So what will we get from Pythagoras theorem? You can use the Pythagoras theorem. H is equal to root of hypotenuse square minus base square. We will get x square by 4. So as per the question, it is given that d value is very smaller when compared to the length of the string. If d is small, x is smaller than d. Okay, so d is the initial distance. When the sphere starts to move towards each other, it's then the distance between them will become x. So the x will be less than the d. So this is also very less than the L value. So we can simply ignore this. On comparing to the L, the value of x is too small, so we can ignore this. We can take that value as 0. Okay, so we will be left with h is equal to root of L square, and the square and root will get cancelled. Value of h will become L. Okay, so this is given in the question itself. Okay, the value of d is very less than L, is much less than L. Okay, so we are using this, so you will get h is equal to L. Now find the value of tan theta from this triangle. You can find the tan theta is equal to opposite side by adjacent side. So the opposite side is nothing but x by 2 and the adjacent side is L. Okay, so this will become x by 2L. Now you can use this value here. You know the value of tan theta, we can use this value in the equation. Okay, now q square is equal to mg x square is equal to tan theta value is x by 2L. So now I'm going to take the value of x square to this side. So I will get q square by mg is equal to x cube by 2L. So we can see except the q and the x value, all the remaining values are constant. So we can rewrite this equation as, you can simply make all the terms as constant. You will get q square proportional to x cube, and then you have to take the square to that side. You will get q will become 3 by 2. Now just go to the question back again. You can see the charges begin to leak from the both spheres at constant rate. You can see here, read the question. The charges begin to leak from the constant rate. What do you mean by the constant rate? The rate of decrease in charge with respect to time is constant, which means the change in charge with respect to time is constant. Okay, so this value is constant as per the question. Now we have to get the term here, we have to differentiate this. Okay, so just differentiating both sides with respect to time. So on the left hand side you will get dq by dt, right hand side the formula for differentiation d by dx of x power n is equal to n into x power n minus 1. Just writing this here, d by dx of x power n is equal to n into x power n minus 1. So I will get here the value of n is 3 by 2, you will get like this. And also here the variable with respect to I am differentiating and the actual variable both are same, so I am stopping up to this. But in this case the variable with I am differentiating is time, but the actual variable is x, so I have to differentiate the x along with the time again. Okay, this is called chain rule. If the variable with respect to are differentiating and the actual variable in the equation are same, you can stop up to this. If they are different, here the actual value is x and the differentiating term is time, so these two are not same, so I am again differentiating the variable. Okay, and from this also we can rearrange the constant terms. You can take the 3 by 2 to here in the first part, entire first part to here, you will get 3 by 2 will become 2 by 3 dq by dt, and x power this value will become 3 by 2 minus 1 is equal to, you can cross multiply this, 3 minus 2 by 2 you will get 1 by 2. So here you will have x power 1 by 2. If I take this to this side, it will become x power minus 1 by 2 proportional to, you can write the dx by dt as velocity. So you know the change in displacement with respect to time is called velocity. Now so in this equation also this part is constant. Okay, as per the question this value is constant. 2 by 3 is just a number is also a constant, so we can just ignore them. V. Okay, so let's check the option. So this is in option A, V proportional to x power minus 1 by 2. Just I am rewriting this. This is in option A.